discussing about the container orchestration tool called Kubernetes. So in our last session itself, we were discussing about the container orchestration. So how the container orchestration tool like Docker Swarm or Docker Compose can able to create multiple containers, run as a service, and ensure high availabilities by creating replicas. Using Docker Swarm, we cannot handle the production workload. That is the reason we are going to use Kubernetes. So not to work with Kubernetes, first you need to understand the fundamentals, the overview of Kubernetes, and you need to be clear with the architecture of Kubernetes, and we need to understand the components of the Kubernetes architecture. So when I say components of Kubernetes architecture, what are the workflow, what are the components we have in Kubernetes? It is must to have, right? And then you need to understand how to install and configure Kubernetes architecture, correct? And then your Kubernetes concepts, right? So like this, we'll be discussing about each and every concepts one by one, and it's all very much important, okay, in a real-time environment. So we have a lot many things to go, and gradually we'll see how we can able to work on the real-time scenarios, the use cases and all. First, let's understand the basics, right? So once I complete the concepts, then we'll be discussing about the real-time scenarios, how it can be implemented, where it can be implemented, what is the role of DevOps team in working with Kubernetes for microservice application deployments. Everything I'll give you some real-time scenarios and use cases. So there's a plan for this module. So this concepts, we have a lot of concepts in Kubernetes. I'll list out once we complete this installation process and all. So first thing is overview of your Kubernetes. So when I say Kubernetes, it is an open source container orchestration tool. Right. It is an open source container orchestration tool which is used to manage, deploy containerized microservice based applications. It's a very important thing. It is not meant for any monolith applications. It is promptly meant for microservice based containerized applications. Even you can't use Kubernetes to deploy just a simple microservice based application. It is not meant for deploying your WAR files directly. It has to be containerized. It is promptly meant for the containerized applications. And another important thing is it is used to ensure high availability of the containerized services deployed in prod environment. So how it ensures high availability means by creating replicas, and it also uses self-healing capability. Got it? So using that self-healing capabilities and the number of replicas, we can able to ensure the high availability of your Kubernetes pods. And another important thing is when I say replicas, right? So there is something called controller manager or a controller object like deployment controller objects, replication controller or replica sets that are helpful to enable this replication and self-healing. And another important thing is Kubernetes supports auto scaling and load balancing. Correct. Because these auto scaling and load balancing are two essential features that is required for any production workload. Correct. Let's say I want to deploy my application service in production server. So to ensure high availability, I can have some replicas of production servers. What if the replicas of production servers are not sufficient? I need to quickly scale up the servers. Similarly, if it is no longer required, I should be able to quickly scale down the service. And whenever there is a huge traffic in the network, I should be able to properly route the traffic, correct, to the underlying services and the nodes. So all those things can be effectively done with the help of your auto scaling and load balancing, and Kubernetes supports those two features. That is why it is still popular. So because of these two features, not only these two, these three features, self-healing capabilities, auto scaling and load balancing, these are all missing in your Docker Swarm, as we discussed already, right? So because of that reason only, we cannot rely on Docker Swarm for production implementation. Easy. And we talked about continuous deployment, remember, using the Kubernetes deployment strategies, correct? Using the Kubernetes deployment strategies, the continuous deployment can be achieved. So what are the deployment strategies of Kubernetes? How we can achieve continuous deployment using this? I'll talk about it in detail with a demo. And hope you remember what is continuous deployment. Without any manual intervention, you should be able to deploy your services to target environment. So it is not just about deployment. Consider I have already deployed my services in production environment. It is live now. My web application that is deployed in production environment, it is up and running, being used by multiple users. And I want to do some sort of upgrade. Consider the current version is 1.5. I want to upgrade it to 1.6. So whenever we go for any changes in the production level implementation, definitely it leads to some downtime, right? So downtime, we can able to go with any application upgrade by using this deployment strategy. So that's what the main point here. Continuous deployment can be achieved using Kubernetes deployment strategies without any downtime. Okay, so these are the core features or capabilities of Kubernetes to implement. So why it is this much popular? Who is owning this product means actually this Kubernetes was owned by Google. It was their own product, proprietary product. Okay, if you talk about Docker and all, right? Docker and all introduced in the year 2013, and it gains its popularity in 2015. So in 2015, most of the enterprise organizations they started using Docker because Docker supports the containerization in a very easy manner. You can able to quickly create an image, you can able to quickly publish container registries and deploy it, create multiple containers, and able to independently deploy your applications. It's very much effective. All right. So most of the organizations started to adopt to this process of containerization using Docker, but they get into main trouble when it comes to the production implementation. Got it. So during the prod implementation, because of the Docker Swarm, which is not capable to extend its features for the entire production workload, most of the organizations struggle to implement Docker in production environment. So that is the time where Google has released their product to open market. Okay. Till then, Google was using this Kubernetes. It is their own product. They have created this tool and they were using this product for all their services, for all their Google search engine service, their Google Drive, Google Maps, what are the deployment they do on their cloud platform, all those things they were using Kubernetes, which was their own product. So because of this issue, Kubernetes released this product to open market. And then after, all the service providers like AWS or Azure or any cloud service platform, if you see here, they have started to use that open source Kubernetes, correct? Open source Kubernetes and created their own managed service. So if you see any managed services here, like service providers here, they have their own container service like Elastic Container Service in AWS, and we have Elastic Container Registry and Elastic Kubernetes Service. Similarly, Azure, they have Azure Container Service, Azure Container Registry, and Azure Kubernetes Service. If you consider Google, they have something called Google Container Engine and Google Container Registry and Google Kubernetes Engine. They call it as a Kubernetes Engine actually. Correct. So they have introduced, they released this product as open source Kubernetes, and service providers like Amazon or Azure, they started to use that open source Kubernetes and created their own managed services by introducing some web-based application, web-based deployment strategies and all. Easy. So here we are going to learn about open source Kubernetes. Easy. So when it comes to open source Kubernetes, it is not that easy. Okay, it is not that easy to understand the architecture, and the architecture itself has a lot of components. And not only that, the installation configuration of this entire Kubernetes architecture components is very crucial process. Initial setup will definitely take a lot of time and understanding. But once you set up, once you configure the Kubernetes cluster, right, as per the production standard, then after you can simply forget about it. Kubernetes will take care of the rest of things. All right. So we'll see how to work with your architecture now. So what all things we discussed in our previous module, like Docker Compose, Docker Swarm, right? And networking, we use Docker pod networking, right? How we can able to enable the port mapping and all. So all these things will be part of your Kubernetes concepts again. It is going to use all those features, like how we use your multiple containers to run your service using Docker Swarm, Docker Compose, we can able to do it here also. Easy. So for any DevOps resource, learning Docker alone is not sufficient. You have to be strong in both Docker and Kubernetes. That is what the market expectation now. All right. So I'll explain this architecture now. This is the one. And apart from there is something called Argo CD, OpenShift. A lot of things are there. Say for example, here we are going to install and configure this entire architecture, right? That can be automated through that Argo CD. Like that, we can able to integrate all those things. Similarly, we have something called OpenShift. That is also another product. If you consider AWS, they have their own container orchestration tool like Fargate. Using Fargate also, you can able to deploy this containerized workload. A lot of things are there. So when it comes to the architecture of Kubernetes, we should know first thing is it is based on the Kubernetes master and worker nodes. Kubernetes master and worker nodes. So when I say Kubernetes master, right, it is something considered as a controller through which we can able to schedule the deployments. Worker nodes are the actual node where we actually do the deployment. Correct. So let's understand the architecture now. Then I'll show you how to install and configure it. All right. So let's get into that architecture now. So this is the overall architecture of Kubernetes. Please pay attention, all of you. So it's all starts from the developer. It is a responsibility of the developer to create the application code, and they'll perform the build, create the artifacts, and they will create an application image. Like using Docker build command with the help of Docker file, they can create the application image. And once the image is ready, that image will be published to the container registry, right? So this is what we discussed till last session. Remember, these are all the activities of any developer. Once the image is published to the container registry, that image has to be deployed to the target. Let's say, for example, I want to deploy this image in my production environment. I have 10 different production servers. In all these 10 production servers, I want to deploy this image. So practically, I can't use my Docker run command or Docker Swarm to manage or install these images in the production server, right? And even if one server is down, I can't go and manually spin up a new server and create a new instance of that container there. It's not possible. For that, what we do means we use a Kubernetes, that is a container orchestration tool, through which we can deploy this image in the target environments. And this Kubernetes composed of Kubernetes master and worker nodes. It's architecture component. So when I say Kubernetes master, it is considered as a controller machine, which is primarily used to deploy or schedule the deployments and control the flow of deployments. But the actual deployment will happen on this worker nodes. Like this is worker node 1, 2, and 3. Assume that in this architecture, I have one master node and 3 worker nodes. What is the need for 3 worker nodes means? To ensure high availability of my application, I create some replicas of my production servers and consider that as a Kubernetes worker nodes there. Easy? Now, once the image is ready, once it is uploaded to the container registry, developers will create a manifest file. It is called as a manifest file, which is written using YAML scripting or JSON scripting. It can be in the form of JSON file format or YAML file format. It's just like declarative scripts. Using keys and values, we can able to prepare those manifest file. It is same as like what they have in Docker Compose. Like as I told you already, we'll be writing some script to collect the containers, right? To run as a service. Like that, we create one manifest file here. So what the manifest file is going to hold means, what are all the application I want to deploy, what is the name of the container, which image it has to refer, how many replicas I want to use for deployment, and what is the volume requirement, what is the port mapping, what is the network, all these properties of my application deployment, right? It will be defined as manifest file by the developer. Developer means there is something called Kubernetes developer. Application developers are going to take care of the business logic, but the Kubernetes developers are responsible to prepare this manifest file and support the development team, because by default developers will not have any idea about this Kubernetes deployment process and the manifest file creation. It is the responsibility of the Kubernetes developer to prepare this manifest file templates and share it with the development team. So development team, they just simply fill in the required parameters and update the file. And this manifest file should be part of the application source code repository. All right, as like how we maintain the pom.xml file, how we maintain the Docker file, this manifest file also should be part of the source code repository. Understood? Now, once the manifest file is ready, how I can submit this manifest file to Kubernetes and run that? For that, we use a CLI called kubectl. So kubectl is a command line utility. It's like a CLI. Like for example, if you want to interact with Docker engine, what you use? We use Docker CLI, remember? Like Docker PS command, Docker exe command. So Docker, using Docker CLI, we can able to interact with Docker engine. Similarly, if you want to interact with your Kubernetes engine, Kubernetes master node, we use kubectl, that is a command line utility. So once the manifest file is ready, developer uses kubectl to submit this manifest file for deployment. Once it is submitted, actually we are submitting it to Kubernetes master node. And in Kubernetes master node, there are 4 important components. One is API server, etcd, scheduler, and then controller manager. These are the 4 important components present in Kubernetes master. So the purpose of API server is to receive the incoming request. Whenever you try to interact with Kubernetes master, you are actually interacting with the API server that is integrated in your Kubernetes master node. So with this API server, we just submit a request, and once the request is submitted, right, what will happen? API server will receive the incoming request and it will do the validation. So it will validate your incoming request. The person who submits the request, whether he is an authorized person or not, it will check for 2 things. One is user authentication and user authorization. Once the user is authorized to execute this request, it will check for the manifest file content, the container, whatever they mention, the image, whatever they mention, the properties of the image, whatever they want to deploy, whether it is feasible to deploy or not. It will verify each and everything. If there's any syntax errors or any errors related to the commands or the script, it will be highlighted and it won't allow to proceed further. So the entire user validation and the manifest file request validation will be done by API server. Once the request is valid, it will update the details in etcd. You can consider etcd as a directory or a database that resides in Kubernetes. The purpose of this directory is to maintain the complete information about Kubernetes. It acts as a single point of source of information. Let's say I want to know how many worker nodes are in my Kubernetes architecture. I want to know how many applications are deployed. I want to understand the volume details. I want to understand the network details. Everything, the complete information about your Kubernetes cluster is maintained in this etc. Got it? It is a database that maintains the information about your Kubernetes. And whenever you want to retrieve or understand anything, you have to query this etcd. And the data within etcd, it will be stored in the form of YAML or JSON file format. It's possible. Now, once the request is updated in the etcd, the API server will intimate the scheduler about the new request. Once scheduler got that intimation from API server, it will get into that etcd through API server and understand the request. Based upon the request, it will identify the healthy worker node and assigns that healthy node's details against that request name. It means, consider I placed one request. I want to deploy one container. To run this container, I need around 200 GB of volume, which is of SSD disk. This is my requirement. So which worker node supports this requirement? That node will be considered as a healthy node, and that node name will be updated in the request by scheduler. So it is purely the responsibility of scheduler to identify the healthy worker node for deployment purpose. Once scheduler updates the details in the etcd about the healthy worker node, API server collect the details from etcd and reaches that corresponding node. Okay, the details, whatever scheduler has updated here, API server will take that details and connect to the corresponding worker node. So in worker node, there is a component called Kubelet. So Kubelet is considered as an agent, Kubernetes agent that should be up and running in all the nodes. So API server will interact with Kubelet and share all the details about the deployments. And in Kubernetes, whenever you want to run any containers, it get executed as a pod basically. We use one term called pod. Pod is nothing but the smallest unit of tasks that you run on Kubernetes cluster. I'll talk about pods in detail, but as of now, just keep in mind, we never run containers directly on Kubernetes cluster. Whenever you want to run any container, the containers will be executed in the form of pods, and pod can contain one or more than one containers. Easy. So in general, right, if you talk about Kubernetes, right, we never talk like whether the container is under execution or not. In Docker some we call that term, use a term. But in Kubernetes, we always refer pods, whether the pod is deployed, whether it is up and running, like that, you always consider the pod for deployment purpose. So it is just like, we are wrapping up the containers and running it as a pod, that's it. And which component is responsible to deploy the pod means your kubelet. Once API server connects to the worker node, it will share all the details with the kubelet, which includes the image name. So this kubelet, what it will do means it will share that image details to the CRI. That means container runtime interface. And here we can use containerd as a CRI. So using this containerd CRI, we can download that image from the container registry. All right, this containerd CRI will take that image details, connect to the container repository, and it will just pull that image from the container registry to the cluster. Once the image is successfully downloaded, it is a responsibility of the kubelet to deploy that image in the form of pods. So you can see the circles, right? Consider all these things are pods. So the actual pod deployment will be done by kubelet. So a pod can have a container here. The blocks, whatever you're seeing here within the circle, you can consider it as a container. So a pod can have one container or more than one container, depends upon requirement. But I'll tell you how to do that, right? So once a pod is deployed, it doesn't mean that we are done with the deployment, okay? Whenever we deploy any pod, the pod will be allocated with a unique IP address. Any pod we deploy in Kubernetes, it will get allocated with unique IP address for unique identification. So the assignment of IP address and the deployment will be done by, So what I'm saying here is whenever we deploy any pod, the pod will be allocated with an IP address, and the IP address is something used to uniquely identify the pod. So what is the need for this IP means? Consider I have deployed 2 pods here and I want to enable some communication between the pods. I want to create a network between these 2 containers through these pods. So in order to enable this pod networking, it uses the pod IP address, which will be done through your Kube Proxy. So Kube Proxy is another important component which assigns unique IP address to your pod, as well as it enables the pod networking. Understood? Because there are a lot of scenarios. Consider even in last sessions I told you, right? We have front-end application, back-end application, database layer. So if you want to communicate between these 2 containers, we need to transfer data between the containers. We can use a common volume like that. How the communication between the containers happens here in Kubernetes means by enabling the pod networking. That will be done by your Kube Proxy. Easy? Now, apart from all these things, there is one more important component called controller manager. So which is the 4th component in your master node, which is responsible to ensure that the pod is always running in its desired state. It means assume that as per my request, I just mentioned as 5 replicas of pods. At any point of time, I want 5 copies of pod should be up and running. And out of 5 pods, even if one pod is down, your controller manager will automatically allocate a new pod and ensure that it is up and running as per the desired state. So whenever there is the discrepancies in a pod deployment, or if there is any pod getting into a drain state, controller manager will immediately pitch in and ensure high availability by creating some replicas there. There are a lot of controller manager objects available in Kubernetes. I'll talk about it one by one, but as I understand, it helps to ensure the pod's availability. It always keeps your pods up and running as per the desired state. Easy? So a quick summary now. Once the developer prepares an application image, it will be published to the container registry. And once the image is published to the container registry, developer creates a manifest file and defines all the properties of that pod for deployment. Like what is the name of the pod, what is the name of the container, what is the image they want to use, which version of image they want to use for deployment, what is the volume requirement. All these properties of the pod will be defined as manifest file. Once the file is ready, using kubectl, it will be submitted to your Kubernetes master. API server is something responsible to receive the incoming request. It will validate the user, authentication and authorization, and also it validate the manifest file for correctness. Once the request is valid, it will update the details in etcd. So etcd is the directory or database that maintains the complete information about the Kubernetes and the pods whatever deploy. So once API server updates the request in etcd, the scheduler will identify the request through API server, and based upon the request, it will identify the healthy node from the cluster. Got it? So that healthy node will be identified and assigned against that request. Once the healthy node is identified by scheduler, API server will connect to that node's agent called Kubelet and share all the required details for deployment. This Kubelet will share that image details to CRI, an application image, right, which is there in the container registry. The details will be shared to CRI, that is the container ID we are going to use here. This CRI will interact with the container registry and search for the image. Once image is available, just pull that image to the cluster. Like how we use docker pull command, it downloads that image. Once the image is successfully downloaded, Kubelet will deploy that pod using that image. It creates a pod with a container or with more than one container as per the request. And once the pod is deployed, it has to be enabled with the proper IP address for pod networking. So the pod networking will be done through your Kube Proxy. Got it? And finally, the controller manager, which is responsible to ensure high availability of your pods. It always keeps your pod to be up and running in its desired state. That's it. In this Kubernetes architecture, we've seen some components, right? We use something called API server, what is it called? These are all the components we have seen in this. So through these objects, we can deploy the pods. Okay, so please be clear with this, all these components. Based upon these components, only the actual deployment starts now. So now, in order to work on this, there are some terminologies or concepts. Before I go with the installation, we'll talk about the concepts and terminologies. So even while talking about this architecture, I use some terms like I was using the term like pods, remember? And I use a term like container, image, and we use some terms like cluster, right? So these are some terminologies that might be different. So when it comes to the pod, right? The pod is nothing but the smallest or the atomic unit of task. Okay, the smallest unit of task that you run on Kubernetes is what we call as a pod. And pod executes the container within that. And you see, so we never deploy the containers directly. We just deploy the pod, and containers will be running inside the pod actually. So the containers are nothing but the executable units of container images, and these images are just a static file published in container registry. So when I say published in container registry, this acts as a input for deployment. Correct? So this ultimately acts as an input for your deployment base actually. Clear? And now we have another important term called cluster. So when I say cluster, it is a collection of nodes, config file that defines properties, pods. In order to work with Kubernetes, first we need to understand the cluster architecture. So as we discussed already, it is based upon the master and worker nodes, right? So we'll be having the Kubernetes master. That master can have some worker nodes, like worker node 1. After all these things are virtual machines, okay? We create these VMs in a cloud platform and we consider it as a master and worker nodes. That's easy. So what is the purpose of this master node is to schedule, control. These worker nodes are actual pods are deployed and executed in this worker nodes. So why we need 3 replicas here means even if one node is down, I can use 2 other nodes to support my application. That is the main idea here. That's the reason we create some replicas of production servers. And this master node is also called as control planes. We usually call it as a control plane, right? And this cluster, whatever we're talking here, right? I said it is a collection of worker nodes. So it is a logical unity. So it is just an identity to refer the group of worker nodes. That's it. You see? So now we'll see how to install. And I think before we install, right, I want to talk few more things related to your kubectl and pods, because these are 2 important entities, right? Like I said, kubectl is a command line utility. to interact with Kubernetes master. And pods, as we said, it is the smallest unit of task for scheduling. See, so you have to be very clear with these two things so that you can able to effectively work on your Kubernetes. And what is your role? Like if you are part of your DevOps team and if you want to work in Kubernetes means we have a lot of roles here. Like so either you can be considered Kubernetes developer. There is another role called Kubernetes administrator or Kubernetes security administrator. Correct. So these are three major roles that we can play on Kubernetes environment. If you want to specialize, like consider you're from development background, you want to work in Kubernetes, you want to specialize on Kubernetes means it is recommended to start with Kubernetes developer level, understand how the Kubernetes manifest files are developed, how we can able to create the templates, how to automate the template creation, everything you can understand from this. And administrators are people who are responsible to administrate the entire architecture, starting from the installation and configuration of your Kubernetes, managing resources, everything is completely owned by them. And security admins are going to maintain the typical security process. So the cluster, whatever we define here with more than one nodes, each and every node has its own IP address, has its own port range, enablement, firewall restrictions, right? So the entire security, even if you talk about the API server, right? I told you API server will receive the incoming request. It will validate the user's authentication and authorization. So on what basis you are going to enable the user authentication authorization, everything is taken care by the security administrator. I'm talking on the core, specialization level. Correct. So tomorrow, if you want to specialize on Kubernetes, you can focus on any of these areas for your interest. And we have very good value in market for Kubernetes professionals, especially this administrators and all. We have very good value today. A lot of requirements. Right. Now, let me get into your kubectl first. So listen, please. So as I said already, whenever you want to interact with your Kubernetes, we use a command line utility called kubectl. Whether it is through your manifest file or through ad hoc command you want to interact, that will be done through kubectl. See, the request, whatever we maintain in this manifest file, right? If you want, you can able to execute some ad hoc commands also. Ad hoc commands are commands that can be quickly, used to run on the cluster, the master directly. You don't use this manifest file actually. So few activities you can done through ad hoc commands also. So whether you're going to interact through your manifest file or through ad hoc command, for both the cases, we use kubectl. So how this kubectl works, what are all the various commands it can support for Kubernetes means. So here it is. So ultimately it is a command line utility. And what are the commands it supports means, like you can understand from the syntax here. So kubectl is a utility through which we will run some Kubernetes commands. Commands means it can be like create command, get, describe, delete, logs, exec. Like there's a lot of commands available. Depends upon the Kubernetes resource types. So command denotes the action that you're going to perform here. And these actions against which Kubernetes object you're going to perform. Whether you're going to work on pods, deployments, replica set, services, volumes. So like this, there are a lot of Kubernetes objects are there. So that will be identified with the type parameter. And once you identify the name of the object, type of object, what is the name of the object you're going to use? The name for that object and some additional flag values to filter. For example, if I want to create a pod means I can use a command kubectl create pod followed by the name of the pod I want to create. You see, once a pod is created, if I want to get the properties of the pod, I can use a command kubectl get pod followed by the name of the pod. Assume that nginx-pod is the name of the pod I just created. I want to get the details of this pod. So I can use a git command using some flag value for filter. Great. So the object name can be referred directly or using some acronyms like PO, RS, RC, SVC. SVC means service, right? So this is what your kubectl commands. I'll show you how to create these commands, how to work, how to execute all the stuff. And the very first object we're going to discuss here is about pod. So as I said, pod is just the smallest unit of scheduling, right? So it is just a term we use in Kubernetes to refer to the container deployment. For example, in your virtualization environment world, we use a term called VM. Using VM, we can able to run multiple operating system and run multiple applications based upon those operating systems, right? The same concept has been simplified using containers. In Docker world, use a concept called containers. So it is just like an alternative to your VM. Though we cannot completely replace VM, you can able to reduce the number of VMs using containers. The same terminology in Kubernetes world, we call it as a pod. Though the container is running here, We never call it as a container, we call it as a pod basically. So we're going to wrap up this container within the pod and deploy it in Kubernetes cluster. Easy. So when it comes to the pod, right, you need to understand the pod deployment first of all. How the pods are deployed, that matters. Sorry. Say for an example, consider this scenario. I have placed a request through this manifest file. I prepare the manifest file and submit the request through kubectl. API server has validated my request and it has shared the details with the kubelet for deployment. Now it is completely the responsibility of a scheduler to identify the node. Assume that I have a cluster. This yellow block, whatever you're seeing, it is a cluster. And in this cluster, assume that I have node 1 and node 2. Cluster is a collection of worker nodes, right? So assume that here in this architecture, I have 2 worker nodes. So when I deploy any pod to the Kubernetes cluster, right, it is purely the response of the scheduler to identify the healthy node by default. So if the node 1 is healthy, to deploy all pods can be deployed in the node itself. It's possible. Or you can able to distribute, share the workload between the nodes. It's possible. That is taken care by scheduler basically. Now, once the deployment is done, right, a pod can contain or execute some containers within that. So pod is a collection of containers. All this blue box, what you're seeing here, you can see as a container in the pod, right? And this deployment, it can have one container or more than one container. So any pod you deploy, it can have one container within that, or it can have more than one container within that. It purely depends upon your request. It is recommended. Technically, it is possible to run more than one container within a pod, but as per the process, it is not recommended. We never encourage people to deploy more than one container within a pod. Due to maintenance reason and to ensure high availability, we always recommend people to use one-to-one mapping. A pod can have one container. That is the basic requirement. So in which scenario we can have multiple container means, like consider this is my main container. Okay, so this is my main container and I need some aid. I need some support for this main container. So that can be done with the help of my supportive container. Okay, so I cannot consider this as a replica of main container. It is not possible. It's not like that. We never create replicas of container within the pod. If you want, you can create another pod with the replicas. That's possible. I can consider these are the replicas, but we never create replicas within the pod because if you lose a pod, you'll be losing all the replicas. So if you want, you can able to maintain some sidecar or the support containers to generate some data to this main container. It is possible. All right. But as per the recommendation, it is always recommended to have one pod with one container. Easy. Now, how the pod can able to communicate means you can able to deploy multiple containers, okay, or multiple pods within a cluster. So that can be done with the help of your pod networking. So this is what something you can compare with your networking on your containers also. So listen, please consider a scenario. I have deployed 2 pods, pod 1 and pod 2, right? So as we discussed already, whenever we deploy any pod, the pod will be allocated with a unique IP address, correct? This is IP. And assume that the pod 1 is having 2 containers. One is a main container and another is a supporting container. Similarly, this pod 2 is having a main container. So whenever we run any main container, any container within the pod, the container will be having its own port number. Let's say I'm running a Tomcat application in this main container. So I can have a port number like port 8080. Assume that I have some monitoring tool or metrics as I want to capture, so that I use a supporting container means it can be running as a service within my container. So these port numbers are the identity to this container basically. Correct. So now whenever we deploy any pod, the pod will be allocated with the IP address and the container will be identified, the application will identify port number. So the identity of this container is IP address followed by its port number. Similarly, identity of this container is the IP address of the pod along with its port number. Same way for this container also. IP address of this pod along with the port number. So this is how your pod IP will be allocated. Every pod will be having its own unique IP address that will be created with the help of your Kube Proxy. Easy. Pod IP address will be created by the Kube Proxy. It is another utility that runs in your cluster. So this is about pod networking. So now when it comes to the communication between the pods or between the containers, there are 2 levels here. One we call it as interpod communication. Another thing is intrapod communication. When I say interpod communication, it is the communication between the pods. Let's say I want to connect between pod 1 and pod 2. So how I can able to establish connection means by using the port number, IP address of the pod. I can able to communicate between these 2 pods. It's possible, right? That is what even I was showing you here in the previous slide. If this container wants to communicate. When I talk about pod communication, right, actually it is a communication between the containers, not between the pods. What is the purpose of connecting 2 pods means containers within the pod has to communicate between each other. So I want to communicate between these 2 containers. Main container of pod 1 wants to connect with main container of pod 2. So how the communication happens means with the help of the pod IP address. That's the reason pod IP is considered as a common entity for all the containers within the pod. So using pod IP address, we can able to establish a connection between the pods, and containers can able to communicate between each other, right? From one pod to another pod through this IP address and the port number. And there is something called intra-pod communication. So this intra-pod communication means it is between the containers within a pod. Assume that I have pod 1 with two containers. How this main container and supporting container communicate with each other means here also it can either use the IP address of a pod along with its port number, or within the pod, if you simply say local host means followed by the port number, we can able to establish connection to that server. The same as like how we use in your VM also. So in your local machine, if you run any service, you can directly use localhost followed by the port number, right? Similarly, within your pod, you can log into the pod, and if you say localhost followed by this service port number, you can able to establish connection between the containers. That is pod. You see. So as far as this pods are concerned, you should know how the pod deployed and the pod networking. Here we have something called pod networking and interpod networking, right? And you should know how to use that IP address. And another important thing here is the pods, whatever we call these pods, are not the permanent entities. Pods are not the permanent entities. We talked about this in container Docker itself. At any point of time, we can lose a container. Containers will not run permanently due to some application issues or network issues. Whatever happens, containers might get into drain state. Similarly, pods also. Correct. Pods also will get into drain state. So we cannot rely on the pod and its IP address for the permanent communication enablement. For the enablement of the permanent communication with the pods, we use some Kubernetes services like cluster IP service, all those stuff. We'll talk about that in detail later point of time. But as of now, understand, pods are not the permanent entity. And once a pod is deleted, that IP address removed from that. So till your pod is alive, you can use that IP address of the pod. Once a pod is deleted, you cannot use that IP address of the pod anymore. Correct? So that is how your pod is designed to run. So this is about the core concepts and the terminologies of Kubernetes. And we have a lot of things, okay? Like throughout this module, what are the Kubernetes concepts we're going to discuss means with the demo, I'm going to show you how to work with your pods, your Moricon, say like services, or before that we'll talk about the controller objects. We are going to talk about replication controller, replicas set, what else? Deployments, daemon set. Okay. And we have something called services. We'll be discussing about node port service, cluster IP, and load balancer. Load balancer is a paid service. Okay. Load balancer is not actually the service from Kubernetes. It is a paid service from the service provider. We are going to use the load balancer service in Kubernetes. It is only paid service and it's a costly service. And we'll be talking about the Kubernetes volumes like config map volumes, secret volume, and we'll be discussing about the host path volume, and we'll discuss about persistent volumes, and we'll discuss about the persistent volume claim, right? So these are the core concepts you're going to discuss with the demo, and also we'll discuss about namespaces. It's also another important topic, okay? And we'll be discussing about the Helm charts, okay? So these are all the topics we're going to cover as part of Kubernetes module. It's all very important and essential for your implementation. All right. So to work on all these things, first we need to set up the cluster. So you see the term somewhere, right? Installation Kube configuration. Okay. So first we'll see how to install and configure the Kubernetes master node and worker nodes. Right. So for this demo, I'm going to use the same architecture. Like we can have one Kubernetes master and two worker nodes for the sake of demo here. Okay, so I'll be launching 3 VMs in our AWS console through AWS console, and I'll consider one node as a master node and two node as a worker node. And I'll show you how to integrate these nodes and set up the cluster. Installation and configuration, it is really a lengthy topic, and it requires a lot of dependencies, components to be maintained. There are a lot of steps involved. So we'll talk about all these things one by one. So if you want for the learning purpose, you can use your Minikube, but it is not recommended in a production level implementation. So for this installation configuration, we can use a concept called kubeadm. Using kubeadm, we are going to configure this Kubernetes master, right? Okay, so let's get into this installation procedures. So as like how we managed our Jenkins master and Jenkins slave nodes, we are going to discuss about the installation configuration of your Kubernetes master and worker nodes now using kubeadm. So let me get into the official page. I have prepared a separate documentation as like how we prepare for Jenkins. And this is the official page from where you can able to download Kubernetes. So if you get into this official page here, you can get into the production environment and installing Kubernetes with some deployment tools where you can see bootstrapping through kubeadm. So this is what we're going to do actually. So I'll keep this link in your document here. So this is the official page. If you click on this link, it will directly take you to this page. And we have the latest version of Kubernetes version 1.31. And what you can do here is you can use any of the previous versions also, not a problem. So before you actually install Kubernetes components, there are some prerequisites. As per the recommendation, we have to take care of the hardware and the software related prerequisites. So when it comes to the Kubernetes master and worker node, it is compatible to have Linux machine, and any system which you use, whether it's a master or worker node, it should have at least 2 GB RAM or more than 2 GB RAM. That is the recommended configuration. Similarly, CPUs, it should have at least 2 CPUs basically. Got it? And apart from this, there should be a full network connectivity between all the machines. This is also a recommended one. Why we need a full network connectivity means, like for example, consider I have Kubernetes master and worker nodes. So there should not be any firewall restrictions between these nodes, as well as there should not be any port number restrictions or no access restrictions there, because it is a responsibility of a scheduler to schedule your pod deployment, and it can able to create any number of replicas and swap the pods during the deployment. So whenever we try to swap the details or pods, there should not be any firewall restrictions there. That is the reason we should maintain a full network connectivity, and it is recommended to have a unique host name for reference. Why? Because whenever we create any VM, by default the VM will be referred with the help of its IP address, the private IP address, and practically we can't use a private IP address for longer term. Okay, if you want to quickly refer to the node, we should assign some unique host name for that node. That's the reason it's recommended to have unique host name, and there are certain number of ports has to be opened. Okay, so what are the ports means, you can click on this link and understand what are the ports to be enabled for your configuration. Correct? And then once your hardware component is ready, the next thing is we have to install the container runtime. There are a lot of container runtimes available, like Containerd, CRIO, Docker Engine using CRI, Dockerd. This is also a container runtime interface we can use. So Kubernetes supports these 3 types of container runtime to be installed and configured. And also we have to create a swap configuration. We should disable the swap so that your kubelet can able to deploy your pod. So in order to effectively use your kubelet for deployment, we use the swap option as false. That is another prerequisite for deployment. And once the Containerd is installed, then only you can able to install the Kubernetes components like kubeadm, kubelet, and kubectl. And for the installation of Containerd itself, there are a lot of procedures involved. Like it is having a lot of prerequisites, starting from the IP6 table reference updates, network filter, and downloading the Containerd package and installing it and running it as a service. A lot of things are there. And then you have to install this Kubernetes components. And this also has some prerequisite. We have to download the required packages, then only you can install and enable it. So I'm going to use this entire documentation to install the Kubernetes cluster. But if you go through this document, I don't think you can able to quickly understand the process, because the document contains some details. Okay, like through some link, they routed to your page, and from there you'll collect more information. Like that, no, you have to navigate with more than one pages. Maybe if you start using it, you'll get to know about one by one. But maybe for the very first time, it is very difficult for you to understand understand all the dependencies. So for that, what I did, I have prepared this particular document. So here I have documented each and every step that is required to configure your Kubernetes master and the worker nodes. So first step is we are going to launch 3 nodes, and I want to consider all these nodes using Ubuntu 20.04 version. All these things are of Ubuntu node. And once the nodes are launched, as we discussed, there should be a full network connectivity between the nodes, right? There is a prerequisite here. And also certain number of ports has to be enabled. So for that, we have to enable the port numbers. In master node, there are a certain number of ports. In worker node, there are a certain number of ports has to be enabled. So if you want, you can able to enable each and every node by yourself manually, or you can just for sake of demo, I can allow all traffic for now. But in real-time environment, we cannot allow all traffic. You have to explicitly open these ports with proper approval from your infra team. Correct? That is one thing. And once the ports are enabled, there are certain packages and commands to be installed in all the nodes. That is on master and as well as in the worker nodes. And there are certain commands that has to be executed only on the master node. Similarly, there are some commands that has to be executed only on the worker node. Correct. So your entire installation process involves a lot of steps. So if you want to understand the commands that has to be installed master, first I'll update the default packages and I will change the host name, because as per the recommendation, if you can see here, we can able to assign the unique host name for your machines. So for that, what I did, I use the system command, host name ctl command to set the host name. Once the host name is defined for all these nodes, then you can able to install Containerd. Optionally, if you want, you can able to install docker.io using for Docker and you can install Containerd. For the installation of Containerd, there are some prerequisites like we have to load the net filter module, we have to allow the IP6 tables, as well as we have to download the a Containerd package and then install it. So using curl, we are going to download the Containerd package, and once it is downloaded, we can able to install it. Once Containerd is installed, then you have to manage the configuration file for Containerd. We are going to manually create one config.toml file, and with that file, we are going to manage the container. What is it called? Containerd. So it's all a manual process. Okay, so we cannot rely on any other tool to set up this. So it's all like, if you want, you can able to write some shell scripts and automate through Ansible kind of thing. That is a different story. But these are the core steps we need to implement here. And once Containerd is installed, we need to ensure that the Containerd server is up and running. And finally, we can able to install the Kubernetes components like your Kubelet, kubeadm, and kubectl. This package also has to be downloaded, and then only you can able to install it and ensure that your Kubelet agent is up and running. Now, once it is done on the master node, it means out of 3 nodes, which node you want to consider as a master node? On that node, we need to run kubeadm init command. So this will initialize that node as a master, and it enables all the required Kubernetes components like API server, etcd, scheduler, controller manager, Kube Proxy, Kubelet, everything will be configured there. And once the kubeadm is done, your control plane will be up and running, and you can able to follow certain steps that is provided by the installation module. And finally, you run a kubeadm join command on the worker node to attach that node to the Kubernetes master node. That's it. So this is how we manage it. It's a very lengthy process, I agree. So, but it is not difficult. Okay, it is not at all a difficult process. It is a very lengthy, but still, if you understand the workflow, it's very easy. The commands, whatever I'm going to share, it's all something which I use in real-time environment. It is something I copied or accessed it from the real-time scenario, as well as taken from the official page from here. It's a mix of both the things. Swap has to be disabled in order to make your kubelet. Kubelet is the agent, right? So which is responsible to deploy a pod. So in order to make the kubelet to effectively deploy your pod in the nodes, you have to disable the swap. So let's get into this node now. Okay. We'll get into this just a second. Okay, so I'm going to launch the EC2 instances now. So let's use Ubuntu 22.04 version, the previous version of Ubuntu, which is considered as a stable version. And for the sake of demo, I can use T2 Micro itself. Okay, but in real time, we cannot use T2 Micro because it comes with just 1 CPU and 1 GB RAM. As per the requirement, we should have at least 2 GB RAM, right? And 2 CPUs, correct? But if you use T2 Micro means you'll be getting only 1 GB RAM and 1 CPU. Definitely it is not sufficient to make this successful. But I'll show you there are some alternative steps we can follow to use your T2 Micro. That is the reason, if you can see my installation process, when you use kubeadm init command, we can simply say kubeadm init followed by the pod network CADR. This pod network CADR is used to define your pod IP address. Based upon this CADR range only, your pod IP address will be created. In a production environment, you can use this command, but here we are using the instances which are less than the actual configuration. So if there is any issue occurs because of the number of CPUs and memory, we are just giving instruction to ignore it. So definitely it will capture that issue and it consider it as a warning and proceed further. It won't interrupt the process. Right, easy. So let's create T2 Micro itself, and I can use the existing key pair, which is available on my machine, and we'll be launching 3 nodes now. Easy. So it's very simple. Just choose Ubuntu 20.04 version as an AMI, and T2 Micro. Your key pair is the one which you already have, or you can create a new one, and ensure that you choose number of VMs here itself, like 3 VMs, and launch it. It's done. So I want to make it as worker node 2. All right. So we have all the nodes up and running now. And once the nodes are ready, the next step is to update the port numbers. So if you want, you can able to update add each and every port as a inbound rule. It's possible, but for the matter of time, what I can do, I can simply allow all traffic for this demo. So go to the security group. This is a security group associated to all these instances because we launched instances at the same time, right? So select the security group, edit inbound rule, add rule, and say allow all traffic for now with this CADR. That's it. Or if you have time, you can just add one by one. That doesn't matter. Okay. Now, once the port numbers are enabled, next we need to connect to all these nodes and execute these commands one by one, all the nodes. Okay. So now let's get into this node. I'm going to connect to node 1 now through MobileXterm, node 2 and node 3. I mean, this is worker node 2. This is worker node 1, just for a reference. Okay. And this is my master node. Okay. So once you establish a connection to these nodes, it's visible, right? So now let me elevate my access to root level, sudo -1 and update the packages. Similarly in this worker nodes also. Okay. So we are just updated the default packages, and let's change the host name for each machine. So there is a command called hostnamectl set host name. Why? Because if you see, this node is being referred with the help of IP address. Okay, so sorry, every time I cannot rely on this IP address for reference, so I can simply change the name to kmaster node. It's a master node, and exec bash. See, now the node name has been changed to Kubernetes master for this node 1. And even after reboot, you should see this name is available here. That's what matters. Similarly, update the name for worker node 1 and worker node 2, right? So it's all basic Linux commands, okay? It's available in your doc. I'll be sharing this document with you today. And once it is done, I told you we have to disable the swap. So to allow the kubelet to work properly, we need to disable the swap on all the machines. So there's a command you can simply execute to disable the swap. All right. So once this is done, if you want, you can install Docker, or it is optional. Okay. I'm just having this. If you want, you can install it. Otherwise, it is completely optional because we are going to manage it through your containerd. And for the installation of containerd, first we have to update this net filter module, and then we have to update this IP6 table references. And then if curl is not present in your machine, you can install curl. And then using curl, you can download the containerd package. In latest version of Ubuntu machine, curl will be part of the default package, so you don't need to install it explicitly. But if it is a previous version of Ubuntu, or if you're using CentOS and other stuff, in that case, you have to install it explicitly. That's the reason I added this command here for your reference. So now let's update this net filter module. Still in progress. And you can update this as well. IP6 table reference. Once this is done, you can update this because we just update the config file, right? So without restarting your node, if you want to apply the settings, you can simply run this command. You just refresh it and make that immediate impact of the changes what we made here. And then now you can try with this curl command. Okay, like if you simply say curl, type it install curl. If curl is already available, it is not going to install anything. So it means curl is available in the default version. Okay, so it's already having the latest version. So you can directly use a curl command to download the containerd package. So use this command, download the package first, enter. Similarly, execute these commands in all the nodes. Okay, now once this is done, all that you can do here is you can update that package, whatever we have downloaded, and install containerd. All these 3 nodes I'm doing now. Once this containerd is installed, okay, this is just a process of installation. And once it is installed, we have to create one directory called containerd directory, and within the directory we need to create one config file, config.toml for config. So it is nothing but the package whatever you installed that you're going to copy into this and create a new file here. That's it. That's it. So once this file is ready, all that you can do here is you need to edit that file. Okay, I just documented here. We have to modify that config file to ensure that the control group driver is configured. So to do that, edit the file using VI editor and go to this group and change this systemd group as true. By default, it will be false. Just change it to true here. That's it. So just go to your config. Let me edit the file first using VI editor. We are going to edit this. Go to insert mode. Just scroll down. Okay, go till the end of almost end of the page, and you can find something called the systemd group. It is available in containerd runtime.runc options. Okay. So from this, you can execute your command. I mean, change the parameter. By default, is false. Just make it as true and simply save the file. That's it. Similarly, run the same command to edit the file in all the nodes. So we just updated all the configuration. Now your config file, I mean, containerd package has been successfully installed and updated. Just ensure that you restart containerd service. We are running this containerd. It is up and running now. You can see it is active. And once this containerd is up and running, all that you can do here is you can install Kubernetes. For the installation of Kubernetes, first let's update all the packages. Because of containerd, if there is any packages to be updated, we can update those packages as well. See here. And then we have to install this CSR, just a dummy package, which can be availed from GCP because it's all part of that open source Kubernetes package. And once this is done, we have to create one folder called keyrings folder. Within that folder, we are going to download the keyring. Once keyrings folder is downloaded, just created, use a curl command to create the keyring in that folder. It's just a process of copying or downloading it to the directory. Right. Now, once keyring is created, then we have to override that property configuration with that Kubernetes list. So there is a list we are going to update with the keyring. So let me run that command as well here. Okay. So if you observe here, I'm using Kubernetes version 1.29. Okay, so I'm just updating that release package in this directory. So once it is downloaded, I can able to simply update the packages, whatever we have created, extracted now. And finally, we are going to install the Kubernetes components like kubeadm, kubectl, and kubelet in all the nodes. And once it is installed, finally, you can enable the kubelet agent in all the nodes. And it's all available from this document. Okay, the document, whatever I shared with you, right? It is there in that official document actually. So this entire content is based upon this document. If you can scroll down here, you can see we update the packages, we have downloaded that cert, and we have just created that keyrings folder and copied that keyrings to the directory. And then we have updated that Kubernetes list and finally install these components, right? So that's it. So these are the things we have to enable in all the available nodes, including a master and worker node. And once this is done, only on master node, we have to run certain command. That is, we have to use kube init command. We have to initialize that node as a master node using this pod network CADR. So what it is going to do means it is going to download all the Kubernetes related components in the form of image, like your API server, scheduler, controller manager, your etcd, Kube Proxy, Kubelet. All these things will be running as a pod internally. So to run the pod, we need an image, right? So the image can be first downloaded and then it initializes it if it is not present. Or if you want, you can explicitly use a command, kubeadm config images pull command. So out of these three nodes, which node you want to consider as a master node? On that node, just run this command, kubeadm config images. So we are running this command only on the master. Okay, just make a note of it. So now it will pull all the required images. So the latest version is 1.31 and we're using 1.29. That doesn't matter for now. Still, we have support for that. That's it. Almost all the Kubernetes components like API server, controller manager, scheduler, Kube Proxy, or DNS, all these services are downloaded. And next we are going to use kubeadm init command along with the pod network CADR. So this is a range of pod IP address. I told you whenever deploy any pod, the pod will be like the unique IP address, right? So based upon the CADR range, only the pod IP will be created by Kube Proxy. And this IP address also is based upon the network plugin that we use. And since we are using our T2 micro instance, these two parameters are mandatory. Otherwise, your initialization will fail. So just copy this and run this command only on the master node. See what happened here? It was trying to set up the configuration and it is considering the number of CPUs. The number of available CPU here is 1, which is less than the required. Similarly, the amount of RAM which we have is less than the actual requirement, but still it is considering it as a warning and proceeding further, right? And if you can see here, your process, it is completed. Your Kubernetes control plane has been initialized successfully. And once it is successfully initialized, there are some post installation process, like we have to assign some access to the user to run the kubectl commands, and we have to enable the pod network by using the network plugin, and then we have to run this command, kubeadm join command, only on the worker nodes to attach that node to the Kubernetes master. So these are three important activities we need to perform now, right? So first thing is, as I told you, if you want to interact with the Kubernetes, we'll be using kubectl. So now in this master node, I'm running this command as a root user. As the root user, if you want to interact Kubernetes, that user should have some privilege. Or tomorrow you can create any user, like a DevOps admin user or any user you create, that user should have access to run that kubectl commands, right? So for that, what we do here is we just update that root user home directory with the Kubernetes config file. So we're going to create one folder called .kube, and within that folder, we're going to copy the config file, which is available in the system directory to this home directory of user, and then ensure that that file is accessible only by the owner. We're just going to change the access mode of that file. That's it. So any user who's having this particular file, config file, they can able to interact with Kubernetes master, correct? So we have to run these 3 lines of code. Don't worry, it is already updated in your document here. So you can simply follow my document. Just follow only the executable statements, okay? Ignore the commented lines and have it here. That's it. Once this is done, the next step is you should now deploy a pod network to the cluster. For that, we need to use kubectl apply command to set up your pod network. So here to set up the pod network, we use some plugins like funnel network plugins. So here is a command, kubectl command to install this funnel network plugin here. So what is the need for this network plugin means? I told you your Kube Proxy is responsible to assign the unique IP address of your pod and enable the pod networking, right? So how that Kube Proxy work means it is depends upon the plugin here. So this is the plugin which is required, which is used by Kube Proxy to enable this pod networking. So that has to be done actually. So we just installed it, and it will also run as a pod internally. Okay, to create one dedicated namespace for funnel network plugin and creates some pods related to the network plugin, right? Now, once this is done, almost your initialization, everything is over. Okay, there is a command called kubectl get nodes command to get the list of nodes that we have configured. So as of now, you can see we have only Kubernetes master node, which is in ready state, and it is considered as control plane. Got it? Like this, we have these two nodes available, right? It's all just a VM we just created. So you need to attach these nodes to Kubernetes master. So in order to attach these worker nodes to Kubernetes master, you can see as part of the initialization, it has given one command, kubeadm join command. So just preserve this command. This is what you need to run or execute in your worker nodes. So this is the only command that you run in the worker node to attach it. Right. So if you can see here, kubeadm join, this is the IP address of your master node and this port number. So all your worker nodes can interact with your master node through this port 6443. That is the reason initially I told you there are certain number of ports to be enabled, right? In the master node, if you see, we have the port number 6443. What is the need for this node means? It helps the worker nodes to interact with the master node. All right. And here, how the master node and worker nodes are authenticated means by using the token. Kubernetes uses the token-based authentication actually. So that token will be automatically generated as part of your initialization. That's the reason I told you to preserve this command along with the token here. So once you run this command in your worker node 1, you can see your node has been attached to your control plane, and it is giving a recommendation to run the kubectl get nodes command on the control plane to see the nodes joined to the cluster. So just copy this command and run it here. See, one new node, worker node has been attached. Earlier it was having just master node, now it is worker node is attached. So similarly, you can run another join, uses the same join command another node. See, worker node 2 also getting added to your control plane. It is not in ready state, but in few seconds it will be up and running. In few seconds it will be in ready state. Okay, so this is how we set up your Kubernetes master and worker nodes and attach the nodes to the control plane. So like this, we'll be using this join command along with the token. So at one point of time, right, say for example, today we just have 2 worker nodes attached to this master. Down the line, after a month or 2, if you want to attach more number of worker nodes to your control plane, you will be using this kubeadm join command. But if you miss this token, you can able to generate this token dynamically. For that, you can use this command, kubeadm token create command. Run this command on your Kubernetes master node to create a token. See, a new token will be generated with the complete command. Just run this command in the worker node which you want to attach. Easy. So this is how we set up the cluster. And another important thing is there's something called kubectl get pods -- all namespaces. So if you can see this command, you can able to get the list of all namespaces that are up and running. You can see your etcd, API server, controller manager, Kube Proxy, scheduler, front in the core DNS. All these things are the Kubernetes components which are responsible to run your Kubernetes master and the cluster. So all these things should be in running state. Then only your Kubernetes cluster is successful, it means. Correct? So if you properly follow all these steps and taking care of all the dependencies, all the core Kubernetes components should be up and running. If any one of these components is not running, then there is some issue. You have to reset up the entire thing. And you can see these are the pod names and this is the namespace. Namespace are just the logical grouping of your pods. Cluster. The grouping of your cluster. So we have a dedicated namespace called Kube system for your core Kubernetes components. And we have installed the network plugin, right? If you can see here, I use one command kubectl apply to install this funnel network plugin. So kubeflownel is a network plugin that is installed to help the Kube Proxy to enable the pod networking. So in order to enable the pod networking, we use this funnel network plugin, and based upon the network plugin only a pod IP address range will be assigned. So that it has created a separate namespace and running it actually. So it is just a plugin we installed to set up your pod networking. That's it. So now that our cluster is up and running, okay, we have attached these 2 nodes. So this is how even your basic Docker Swarm also. Okay, but this is very much reliable and compared to Docker Swarm. So let me clear this, and now we'll see how to work on these things. So the very first concept is about the pod, right? So you should understand, okay, how to use your kubectl commands. We have something like kubectl get nodes, kubectl get pods, and kubectl get all that namespace. You can use get pods all namespaces. Okay. So for example, consider this is my master node. Here, if I say kubectl get nodes, I can able to get the list of all nodes. Similarly, if I want to get the list of pods, I want to know what are all the pods up and running in my cluster. So if I simply say kubectl get pods, see, it says no resources found in the default namespace. So there is a namespace called default. So whenever we create any pod, right, user related, application related pods, it'll get deployed in this default namespace. But if you want to get the list of all pods running in other namespaces, you can use all namespaces. Yeah. So we have kube system namespace, which is running all the Kubernetes components. So like this, there are a lot of namespaces available. If you see kubectl, get ns, there are some namespaces like kubekernel, node lease, public system, and default. So whenever we deploy any pod, by default get allocated to this default namespace. That's the reason as of now there is nothing we have created, so no resource found. Easy. I'll talk about namespace in detail. Okay, we have that in list. I'll talk about that in detail while we progress. But as of now, understand namespace is just a logical grouping of Kubernetes cluster. That's it. Now we'll see how to work with pods. Okay, the very first concept here is about the pods. So we'll see how to create the pods. So whenever we talk about the pod deployment, right, I told you there is something called manifest file, right, which can be written using YAML or JSON file format. There's no issues. Kubernetes supports both the things, and we'll be using your YAML file notation. So in this case, in order to create a YAML file, you need to understand what are the keys, what are the possible keys and pairs you need to use there, key value pair actually. So let me show you one example here. If you have your XML, initially you are using some XML files, right? So the XML file, whatever we use, it's all based upon the tags, right? So those tags are used to manage your data within the XML. It's like a database. Even if you see your Jenkins also, Jenkins database, whatever you use, whether it is a user database or job profile, whatever you use, it's all uses XML file format. And the simplified version of XML file format is something we can consider JSON file formats, which is based upon keys and values. And similarly, we have something called YAML files that is also based on keys and values. So if you want to create any Kubernetes manifest file, it will be based upon the keys and values. Okay. So just look into the scenario here. So this is the process flow for your pod deployment. Listen, please. So consider I want to create one manifest file and it will be in the form of YAML file format. Okay. So the file name is test-pod and the file extension is .yaml. And any manifest file we create, right, it will be having 4 important keys. One is the kind key. Second thing is the API version. Third is the metadata. And then the spec. So for any Kubernetes manifest file, these 4 keys are mandatory. So the kind key, it is used to identify the type of the Kubernetes object that you're going to create. Like if you want to create a pod means, you can use a value as pod. If you want to create a deployment object or replica set or a service, you can able to use that and be there. And the API version is something based upon the type of object. So for pod kind of object, the API version will be V1. So it is considered as a core object. Okay, when Kubernetes was introduced, the very initial version of Kubernetes was having these objects. So under the core group, we have pod. So that's why it's called as API version V1. For deployment or replicas and all, it will be different. I'll show you how it differs and all. And the metadata that is used to identify the name of the pod. If you want to create a pod means what is the name of the pod you want to create? That will be defined by this metadata. Not only that, we can able to assign some labels. Labels are nothing but some additional tags we can assign to your pod or any Kubernetes object. Why? Because we can't always refer the name of the object. We need to apply some labels as some additional tag to apply some filters on that object. Like based upon departments or based upon the environments, we can able to set some labels so that we can quickly filter those objects. Similarly, once the name and the labels are defined, I told you pod is going to run some containers, right? So what is the name of the container? Which image the container is going to use? All this will be defined in the container specification. Spec is used to define the container specification actually. So if your pod is having one container image, just give a name of the container and the image. Here in this example, this pod is going to run 2 containers. One is Nginx container and the thing is Redis container with this image. So for any pod definition, we should have 3 important palms. One is your API version. Then we have something called kind data and then spec. Okay. Please remember these 4 important key pairs, keys actually, and it can be extended. Okay, like it depends upon it. Let's say tomorrow, if you want to attach any volumes or if you want to attach any other additional configuration, we can able to add more content there. All these details are available in your official documentation. Like if you can see this installation page here, I shared this document, right? It's a very good material for Kubernetes. Okay, if you want to understand more features, we have a lot of, like if you want to specialize on Kubernetes, we have a lot of tutorials, your training and blogs, case studies, all this is available. Just explore this. Okay, once we complete Kubernetes module, you can explore this case studies and understand how it is implemented and what are the various companies they are using Kubernetes for deploying their services for your profile. Hope it's clear. Got it. So now once the manifest file is ready, we can use your kubectl command, kubectl create command to create that object. So here I'm going to use kubectl create -f followed by the file name. When I say the file name, what are all the objects we define in that file? it gets created. You can use one manifest file to create multiple objects. It's possible. Okay. And also you can able to use kubectl get command to get the status of that object, whether the object is in running state or in which node is up and running, what is the IP address of that object. All those things can be defined with help of this object here. Easy? Okay. Now just consider a scenario. I have deployed a pod, or I am trying to deploy a pod. There are various stages of pod execution actually. Okay. So that's what we call as a pod's life cycle. So if you consider this pod lifecycle here, once you submit your manifest file, right? I told you using kubectl, you can submit your manifest file and your API server will validate your request and will validate the user authentication, authorization, and the request details, everything. Once it is done, it will deploy your pod to the target node using Kubelet. Till that time, the status will be in pending state. Okay. Till your deployment is done, right? Once you submit your request, your status of the pod will be in pending state. Once the deployment is successful, it will get into the running state. Or due to some reason, if that pod deployment is failure, in the case, it will go to the fail state. You see, it might be because of some user authentication issues or the pod manifest file feasibility is not there. A lot of scenarios. Okay. So whatever the reason, if it's not successful, then it go to the fail state. And another thing is, consider your pod is up and running now, but due to some reason, it is unable to execute the application. Sometimes pod will be up and running, but the container application, it might be failing inside. So in that case also, it will go to the fail state. There are a lot of scenarios. Sometimes the application will be going into loop, or it might not get the expected data and it will fail the transaction, or there might be some data validation failure in the manifest, application logic. So it might lead to any application issues and it will fail the pod deployment. Or if there is no other issues, then it will go to the success state. So as a DevOps team, as a Kubernetes administrator or developer, it is our responsibility to ensure that the pod, whatever deploy, it is up and running. If there is any failure, it should be automatically notified to the developers through some alarms or through some automated monitoring, and developers can able to act on it. Easy. So how to get the status of the pod means by using a command called kubectl get pods. Through this command, we can able to get the status of the pod, whether it's running state or pending state or failure state. You can able to capture those details. So in the next session, we'll see how to create and deploy a pod with some examples, and then we'll see how to log into the pod, and we'll see how to access the applications that are running inside the pod web browser. What is the command to log into running container? So Docker is a command. It is to log into your running container. Similarly here, if you want to log into your running pod, you can use a command called kubectl exec command. Same as like how we use our interactive mode, you can able to use interactive mode followed by the pod name. Okay. And in your Docker module, how you access your application running inside Docker through your browser? How you expose your containers to internet? So remember, we use a concept called port mapping or port binding, right? So using that concept, we can able to expose your container to internet. Similarly, if you want to access your pod through your web browser, there is something called a service, node port service. Okay. So if you want to expose your pods to internet, we can use node port service. So this is the class nodes for Kubernetes. So for this, I'll be sharing this content starting from here. So please consider only the executable lines. Don't consider the statements that are commented. Okay. Just read the statement before you execute. Don't blindly copy paste. Understand the steps one by one and proceed. So this process, whatever we have here, this is still creation of worker node. Yeah, this is the one. Easy. All good.